This video is looking at the question from 2015, Paper 1, Question 8 on the Leaving Cert Ordinary Level Maths paper. Part A of the question tells us that we have a piece of cardboard that is square in shape and its side is 12 centimetre long and we want to find its area. So to get this, we simply say 12 by 12 or 12 squared, which is 144 centimetres squared. In part B, we have the same square of cardboard, except that we have little squares cut out from the corners. And when we cut out these little squares, we're able to fold up the remaining material to make a box. And the question asks us to write down the length of the box and the width of the box. Now, of course, when we fold up either end of the box, the length and the width will just be these dimensions here. So this distance and this distance. So my full distance across is 12, but I've come in by h on both sides. So I've had 12 and I've taken off h and I've taken off h. So my length is 12 minus 2h. And my width is the same because I've got a square starting out. So here I have 12 as well. Take off h, take off h. The width of the box is 12 minus 2h also. They don't ask us to write down the height of the box, but I'm just going to note that because it makes the next part a little bit more easier to understand. So the height of the box is just how tall it will be when I have it standing on the table. And of course, that will depend on how much I have folded up. So the height is just going to be the length of the side of one of these small squares. So the height of the box is just h. So next, they want us to show that the volume of the box is 4h cubed minus 48h squared plus 144h. So since it's a cuboid effectively that I'm getting the volume of, I know the volume is length by width by height. And I have all three of those measurements noted from the previous part of the question. Again, they didn't ask me for height, but like I said, writing it in here makes sense now because I can see clearly what each of these three should be. So I'll multiply them together. And just take your time with expanding these brackets. Don't try to do all three in one go. Take two at a time. I'm going to take the first two brackets and I'll just save the h in a bracket by itself at the end for the next bit. So you'll notice there that I'm keeping a bracket around those first two brackets just to keep all that information together and to make it clear that it'll all get multiplied by h once I've tidied it up. And now I'll multiply out and do my bit of tidying. So multiplying it out looks like this. And now I'll just tidy up a little bit in here. Minus 24h would make minus 48h. And then finally, now that I've tidied up inside in this bracket here, I'm going to multiply the h in, which will give me this result, which is actually exactly what they wanted me to show. I've got the 4h cubed, I've got the minus 48h squared, and I've got the plus 144h. And if you like, you can take this last line and just write it in that order. It's fine as it is here, but you might like to make it look exactly like it looked in the question, like this. Part D asks us what h gives max volume. The key word here is max. So if I've got max or I've got min, I know that it includes a little bit of differentiation and that I'm going to start by finding dy dx and then letting that equal to 0. Okay, so I'm saying dy dx, but obviously here I've no y's and no x's, so what's going on? Well, my variable here is h. So instead of saying dy dx, I'm actually going to call my function f of h, and I can say that f of h equals 4h cubed minus 48h squared plus 144h. And now when I go to differentiate, I'm going to just write it as f dash h. So when I differentiate this, I get 12h squared minus 96h plus 144. Don't forget with max and min questions, I differentiate and then let that equal to 0. So there's my equal 0. And now I need to solve this quadratic here. I can make my life a bit easier though, because if you look at all your values, you can see that 12 divides into each of them. And when I divide, I get h squared minus 8h plus 12 equals 0. Now I need to factorize this and solve. When I factorize, I get h minus 2 times h minus 6 equals 0. And so my two possible solutions are h equals 2 and h equals 6. But now only one of these is the correct answer. Only one of them gives the max volume. The other one will be the one that gives you the minimum volume. So to check which one's which, we need to use our second derivative. Remember, we can call the second derivative f dash dash h. So when I get the second derivative, I'm getting it from this very first line here my first derivative f dash h. I get a minus 48 for this. And remember, it's really the sign that's the important determinant here. If it's negative, it's going to tell me the point is going to be the max point. And so in this case, it is negative. So f of 2 must be the one that I'm looking for. And just to be sure, I'll substitute in my other value 6 and see what happens. And this time I just get 48, which is obviously a positive 48. And this tells me that this value 6 for height gives me my min value. So to go back and address the question, what value of h gives a max volume? Well, it's 2. So I'm going to write this down nice and clearly at the end of my question. The maximum volume is given when h equals 2. Just before we go on to part E of the question, have a look for a moment at why a height of 6 might be the one to give you the minimum volume. If we look back to our original diagram, we can see that we only had 12 in total along the side of the big square. And if I cut in a square, pink square of side 6, then I'm taking 6 off and I'm taking 6 off. So I'm left the distance of 0 for width. And of course, if the box has no width, then it's going to have no volume. And that's why 6 gives us the lowest possible volume. So finally, we have part E. And part E asks us to find the maximum volume of the box. So first of all, we have our function for volume, which is this guy here. So volume, we had decided from back in part C, was f of h equals 4h cubed minus 48h squared plus 144h. So if I want to work out a volume, this is the expression that I must be substituting my values into. Now, I know that h of 2 gives me a max volume. So what I want to do is take this 2 and put it into this function. So I'm going to find f of 2. So I'm filling 2 in for h. And the maximum volume of the box when I sub in 2 is 128. Now, just be careful that you don't lose any marks in any of this. There's something that I should do in part D and part E to guarantee myself full marks. I haven't done it yet. I'll probably lose at least 1 mark in my question if I don't go back and fix it. Any idea what it might be? I need to include my units. So I must make sure to include my units for the height and the distances that are getting measured in centimetres. And the units for volume then will be centimetres cubed.